So I'm giving you a binomial scenario. See if I can pull it up really quick. Probably won't. So I just simulated a binomial for options 0 to 10 with a probability of 0.3, which means it's going to peak where? At 3, because 30% of 10 is here. What is the shape of that graph? Right skewed, right? What if I switch these? So I'm going to switch my outcomes to 0 to 100. What happens with that graph? Peaks at 30. What is the shape of that? Now, I changed my line width so that we could see it better, but what actually happens to that? Ooh, I switched too much. What's the shape of that? Is that bell-shaped or is that skewed? But do I have anything over there? So as my numbers got bigger, my distribution that was skewed, like this, y'all remember where it was. And I have to switch my outcomes. My original distribution was skewed, and there were values down here, right? But as they got bigger, my distribution became symmetrical. So if you do the trials enough, it becomes symmetrical in that portion of the graph, which means you can use a normal approximation. And this is something that is a huge, huge, huge concept later, but we just like to bring it up right now. So as the number of trials gets larger, the binomial distribution gets closer to normal. So this part right here, we can use a normal approximation if your n times p is greater than 10 and your n times 1 minus p is greater than or equal to 10. Well, in context, what is p? Well, in general, what is p? Probability of success. What is 1 minus p? So if I'm taking my probability of success times how many I'm dealing with, I'm getting my number of what? If I have 10, my probability of success is 30%. My 3 is my number of successes. This would give me my number of failures. Expected. So if my number of successes is at least 10 and my number of failures is at least 10, then I could use a normal approximation. And we'll get into a lot of this later about it's more effective when it's closer to 1/2 than 0 or 1. We're talking surface right now. So what do I need in order, if I say normal, that means I can use my what? Normal means I can use my what? Empirical rule, what else? The yellow chart, and what other equation? What equation do I use to be able to use the yellow chart? So what's on the yellow chart? What? There are 2 things on my yellow chart. What's on the inside? Inside is area, outside is, what's my equation for z-score? Do I now have a mean for binomial? Do I now have a standard deviation for binomial? So if this works, that means I can now use this for binomial. Let's do this first. Let's write, you don't need to write this. Using binomial, I want to think about this problem. There's 2,500 adults. That's my what? That's my what? This is my what? And this is what I'm finding the probability of. So if I am doing binomial, I would be doing x is greater than or equal to 1520. How would I rewrite that? Probably that x is. Type that in your calculator real quick with CDF. 1 minus binomial CDF of 1519 is your x, 2,500 is your n, and 60% is your p. What's the first number you plug in with CDF? Your n. What's the second number you plug in? What's the third number you plug in? Your x value, which in this case would be this one. What do you end up getting there? 213 what? So that's using today's method. Well, now, how do I find the mean of a binomial? What's our n? P. So you said I get what? I get what? Standard deviation, sigma is square root of n times p times 1 minus p. Square root of 2,500 times what times what? Which gives me 24 point something. I've got my mean, I've got my standard deviation. So the only thing I would need to know is, can I use normal? Well, n times p we've already found is what? 1,500. Is that greater than or equal to 10? So if we're saying 1,500 of the 2,500 should be successes, how many does that leave for failure? Is that greater than or equal to 10?
Yeah.
So we could use normal approximation. So probability that x is greater than or equal to 1520. I now convert that to a z. Tell me what numbers to plug in. 1520 minus my mean of what? 1,500 divided by 24.4949, which gives you a z value of 0.82. I can rewrite this in terms of z. Now it's probably that z is greater than or equal to 0.82. Yes, I'm going very fast. When z equals 0.82, what is my area in the yellow sheet? Somebody had it out.
I think 793.
793 what?
39.
But I want to do what with that? Which gives me what?
One, 206.
206 what?
1.
Are those really close? So this is using a normal approximation, our guess. This is a binomial, our guess. The reason it's actually off is because something called continuity correction, which is something we don't have to do on this one. I'll just, at the beginning of that tomorrow, write down the interpretation.